Welcome to a new video. In this video, I will show you circle and periodic functions. Without further ado, let's get started. Here we can say that on a unit circle in a standard position, there exists such a relation below. Suppose this is a unit circle. As you can see, this point is 1 and that point is 1 and that point is 1. Of course, these are negative ones. So suppose that we have such an angle, and let's call this point P, where the first value is x and the second value is y. To make it short, we can say that the first variable, which is x, is equal to cosine theta, and the second variable is equal to sine theta, where it is equal to y. Let's take a look at an example here. And in the example, it says if we have such a point P and that point lies on the unit circle, and then find sine x and the cosine x. Well, we don't have to do anything. Actually, you can easily see that it really lies on the unit circle. How? Well, let's say this is y and then this is x, right? So we all know that x squared plus y squared from Pythagorean theorem, this is unit circle, so the radius is 1 here. So we can say that x squared plus y squared is 1. And let's apply it here. The first variable is x and the second variable is y. So just plug those values in our equation, and then let's see what we're going to have. And if we do it, we're going to have negative 2 square root of 2 divided by 3 square plus negative 1 divided by 3 square, and is it equal to 1, guys? If you take the square of negative, then it's going to be, of course, positive. So 2 square is going to be 4. The square of square root of 2 is going to be 2. So we're going to have 4 times 2 divided by 9. Plus this is going to be 1 divided by 9, guys. So 4 times 2 is going to be 8. So we're going to have 8 divided by 9 plus 1 divided by 9, which is equal to 9 divided by 9, and that is equal to 1, guys. And then we can see that, yes, those points really lie on a unit circle. We can check it in this way. So from here, guys, we can say that, yes, sine x is equal to y and cosine x is equal to x. So this is equal to cosine x and that is equal to sine x, guys. We can easily conclude this result. And for periodic functions, we have a definition, and it says a function is called periodic if f of x is equal to f of x plus a for all x values in the domain. Here, the smallest positive value of a is called the period of the function. So as you can see here, if we add a to domain value x, still we get the same thing. And in such cases, a is called periodic. And I have a remark for you guys, and it says the period of sine and cosine functions is 360 degree or 2 pi, guys. These are the same things. And when it comes to tangent and cotangent, our period is 180 degree or pi. Well, what I mean by this is sine, let's say, pi divided by 4, guys. And that is equal to sine 2 pi plus pi divided by 4, guys. Why? Because the period of sine x is 2 pi, so I can easily add this here. So similarly, let's say for tangent x, tangent pi over 4 is also equal to tangent pi plus pi over 4, guys. Why? Because the period of tangent x is pi, or in terms of degree, it is 180 degree. For sine and cosine x, this is also 360 degree. Where we can use those periods, guys? We can use those periods to find the exact value of the function. For example, we have a question and it says find the exact value of the following functions. Sine 750 degree. In order to find the exact value of that sine 750, we can benefit from the period of sine function. Because the period is 360, that means, guys, we can subtract 360 or the multiple of 360s from this angle in order to find the exact value. And once we do it, whatever that angle is, okay, just by subtracting 360 or 2 pi's or the multiple of those values from that angle, and then just make that angle something between 0, this is our value, and 360, guys, okay? So whatever that angle, just by subtracting or adding some values of 360, just try to make this angle something between 0 and 360 so that we can find the exact value. So if you look at here, a from 750, I can subtract 360. If I subtract 360, it's not gonna be enough. I need to subtract one more 360. So what do I mean by that is 750 minus 2 times 360, guys. So it's going to be 750 minus, here we're going to have 720, right? And as you can see, still I'm going to get a positive value. So I can do it. And once you do it, we're going to have 30, guys. So that means sine 750 is actually sine 30, guys. Okay, sine 30, and we know that sine 30 is 1 divided by 2. So this is 1 divided by 2, guys. By the way, I already made a video about how to find the trigonometric values. If you're not familiar with that topic, you can just check it from there. Anyway, so we can say that the exact value of sine 750 is sine 30. And if you want to evaluate this also, this is also 1 divided by 2. Here in B, guys, we have a negative value. If this is a negative value, then we need to make it positive. As I said earlier, we need to make this a value somewhere between 0 and 360. So I'm going to add 360 or multiple of 360s to that angle. Let's see what we're going to have if we add just one 360. Negative 420 plus 360. Still we're going to have negative, right? Negative 60. That means I need to keep adding one more 360. If you add one more 360, then we're going to have 300, guys. That means the exact value is cosine 300, guys. And in order to evaluate cosine 300, okay, just let me write it here. Cosine 300 is cosine 360 minus, let me write it here, minus 60, guys, which is cosine 300. And this angle is in the fourth region, and in the fourth region cosine is positive. So we're going to have from here, this is equal to cosine 60, guys. And cosine 60 is sine 30 also, which is also 1 divided by 2, guys. So B is also 1 divided by 2, guys. If the angle is given to you in terms of pi, then still we're going to do the same thing. Okay, either we're going to subtract 2 pi or multiple of 2 pi's, or we're going to add 2 pi's or the multiple of 2 pi's. So here, as you can see, we can subtract 4 pi from here, right? In C, subtract 4 pi, which is the multiple of 2 pi, right? So 4 times 4 is going to be 16. 17 pi, let me write it here. 17 pi minus 16 pi divided by 4, which is going to be 1 pi divided by 4, guys. So C is actually, just let me write it here, cosine pi over 4, guys. Cosine pi over 4 is cosine 45 degree, and cosine 45 was square root of 2 divided by 2, guys. But the exact value of cosine 17 pi divided by 4 is this, which is cosine pi divided by 4, guys. Here I selected the functions as sine or cosine. If you want to do the calculations for tangent and cotangent, still you're going to do similar things. You will just add or subtract pi or 180 degree or the multiple of those values. Anyway, if you look at D here, it's going to be enough to add just 2 pi, guys, to make it positive. So if you add 2 pi here, 2 times 3, 6, 6 plus negative 5 is going to be just 1. So this is going to be, guys, sine 1 pi divided by 3, guys. So the exact value of sine negative 5 pi divided by 3 is sine pi divided by 3, and that is sine 60 degree, guys. And sine 60 is square root of 3 divided by 2, guys. So just let me write D here. D is square root of 3 divided by 2. So this is basically how we can evaluate the exact value of given functions. And this is our last question, guys, in this video. And in the question it says, find the periods of the following functions. We have 2 functions, A and B. And what we're going to do is we will look at the point, okay, by starting from which point the function repeats itself. This is what we're going to find out. So as you can see, the function starts here, it comes here, and then again it comes this point. So by starting 4 pi, the function starts repeating itself. Why? Because here it's going down, here it's going up, and now at this point the repeating starts. And again it starts going down. So this point, which is 4 pi, is the period of this function, guys. So in A, we can say that 4 pi is the period. For B, these are the functions, guys, f of x or g of x. So I forgot to write those. Anyway, so in B, guys, as you can see, we are starting from the origin and we are going down. And at the point 6, still we are repeating the same thing. At the point 12, we are repeating the same thing. So as you can see, from 0 to 6, the function starts and finishes itself. Okay, and then at the point 6, it is starting repeating itself. So we can say that 6 is the period of the function in B. And these are the last questions, guys, in this video. If you have any question regarding the topic, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.